Good day, everyone. In this video, I'm going to discuss the closure of a set in topological spaces. Now, before that, let us recall first the concept of intersection. So, for example, if we have this one, the intersection of two sets, F1 and F2. Now, this intersection is a subset of F1, and another one, it is also a subset of F2. Now, let's try to look at the illustration of this. If we have these two sets, this is F1 and this is F2, of course, the intersection is found here in between. So, this is the intersection of F1 and F2. Now, as you noticed here, the intersection is just a subset of one of the sets, right? So, it is the subset of F1. Also, it is a subset of F2. So, we will use this later on. For now, let's define the closure of a set. Now, for the closure of a set, say a subset A of a topological space X, the closure is denoted by this, or we can denote it like this. So, the closure is just the intersection of all closed supersets of A. Now, we can write it in this manner. The closure, we have the closure of A, here can be denoted by the intersection of, so it is equal to the intersection of all closed sets. Here F is closed. All closed supersets of A. So in that case, F is a superset of A. Or we can write this as A is a subset of F. Or it is the intersection of all closed sets containing A, or closed supersets of A. Okay, now we will show that the closure of A is closed. Here, we will use Theorem 5.3, the third one. So here, in this theorem here, it states that the intersection of any number of closed sets is closed. In this case, if we are going to get the intersection of any closed sets, then its intersection is closed. Now, in this case here, because this is equal to, because the intersection of any closed set by Theorem 5.3 is closed here. So if we get the intersection of any closed set, then this is closed. And of course, since this is equal to A closure, so we're done showing that A closure is closed. Next, we will show that F is closed here. F is closed and A is a subset of F. It means a closed set containing A. It implies that A is a subset of A closure and the A closure is a subset of F. So, the closure of A contains A and the closed set contains the closure of A. Now, to show this one, we will show two statements. We have A is a subset of its closure, and the second one is the closure of A is a subset of a closed set F containing A. Now, first, let's show this one. To show that A is a subset of its closure, we will let an element in A here. So, let X be in A. Since we know that A is a subset of F, this means that X belongs to F. Hence, if we are going to get the intersection, because it is true for all closed set F, and A, we know that A is a subset of F by our condition. So in that case, this statement is equivalent of saying that X is in the intersection of F such that F is closed from our assumption and A is a subset of F. So it means the intersection of closed sets containing A are all closed supersets of A. Since this is equal to our A closure, so this is equal to our A closure, hence we can say that X is in the A closure. Therefore, A is a subset of A closure because we have shown that X is in A implies X is in A closure. Now, the second one is to show that A closure is in, so let's have here the second one, A closure is a subset of F. So the same thing, we let, say for example, X again, or we could have another letter, Y. Anyway, it's just a representation. So let's have here X is in A closure. Now we know that A closure is equal to the intersection of F such that F is closed. F is closed, just like fish, is closed, and then A is a subset of F. Now in that case, we have here X is in the intersection. It means X is in F. It is in F for all F, for our closed set F. So, for all closed set F. In that case, we have shown here that X is in F. Therefore, we have the closure of A is a subset of F. Follow? Or, we can use the concept itong intersection because the intersection is just a subset of F. Therefore, if X is in the intersection and the intersection is the subset of F, then we can say that X is in F. So, the closure is a subset of F. Now, we have shown the two here. Therefore, we can say that A is a subset of A closure and the closure of A is a subset of F. So, we have shown this statement. Next, we will show that A is closed if and only if A is equal to its closure. So in this case, we will show for this case, okay, because this is if and only if statement. So we will show A is a subset of its closure, and then the closure of A is a subset of A. Now, this is done already in our previous statement. So this is done. And now we show that the closure of A is a subset of A. So again, we let X be in A closure. So we will show that X is in A. Notice that for this proof, our assumption is A is closed. Then we will show this one. So if X is in A closure, it means that X is in the intersection of closed sets containing A. Okay, if it is in that case, so it means that X is in F for all closed set F such that A is a subset of F. Okay, in that case, take note, F is closed and A contains F. Now, our assumption here is A is closed, right? So it means A is one of the F, right? Because for all, this is for all closed set. Therefore, A is one of the F, and in the condition that A is a subset of, A is still correct because A is a subset of itself. Now, if it is in that case, we can say that X is in A. Again, because A is closed and A contains itself. So here, for all closed set F. So A is one of the closed set F. Yes, we have shown here that A closure is a subset of A. So since this is already done, now for this proof, we have shown that A is equal to its closure. Now for the converse of this proof, we assume that A is equal to its closure, and we will show that A is closed here. Now take note, we're done proving already that A closure is closed, right? Okay, A closure is closed. Since A closure is equal to A, therefore A is closed. So, we're done proving this statement, if and only if statement. So that's all about for this video. Now in my next video, I will discuss some examples or examples on how to get the closure of a given set. So thank you for watching and listening.